Or here there is an object which is moving through water, and then it's generating turbulence. Now what you want to do is you place little tiny actuators on top of this object such that they create little tiny anti-turbulences which kill the vortices, such that you can reduce the drag of the object. So the goal is to reduce the drag. And let me show what happens if I run that here. Okay, so here you see a supercomputer simulation of the vortices in the back, and down there here you see what happens after learning. So first we see what happens before the learned behavior is switched on, and suddenly you will see that these vortices get really small because the system has learned to generate anti-turbulence, again through one of these reward optimizing algorithms. And the drag goes down from to 40% of the original value, which was an excellent result a couple of years ago. So that's what you can do. How many more minutes do I have? I still have 10 more minutes. Okay, so I have only 2 more slides to go, maybe 3. I want to put all of this now into this historic context, which is the main topic of this conference. Here we see the beginning of the computer age. 1623, Wilhelm Schickard, he built the first computer. You couldn't program it, but you could do the basic arithmetic operations already, and it didn't have transistors, but it had gears, but nevertheless you could compute with this thing automatically. And then for a long time nothing happened, but then Babbage came along in England. 2 centuries later, in the 1830s, he came up with this idea of having a program-controlled computer, and this is considered as another major milestone in the history of computing. His machines did not work. Even 20th century replicas of these program-controlled computers didn't work. But at least the idea was there. And then we had to wait only 100 more years, 1 century later, and modern computer science started. Because this guy here, Konrad Zuse, he built really in 1941, he completed the first computer that really was working, a program-controlled working computer. And in the decade before that, the foundations of theoretical computer science were created through Gödel, whom we already know, and Turing then took the results of Gödel and rephrased them in this in the context of the famous Turing machines, which are now still widely used in theoretical computer science. And you know, just a few years earlier, this guy, Julius Lilienfeld. Can we see that? Julius Lilienfeld, he, in the 1920s, and it happened within, 10 years or something. Another Austrian, Hungarian, by the way, who also later then emigrated to the United States. And then lots of things happened, but the main breakthrough after that, or the thing that, again, changed everybody's life, or lots of lives at least, was the World Wide Web, exactly half a century later. Now you see the pattern. So Tim Berners-Lee in Switzerland, he came up with the World Wide Web, and within a few years it affected the lives of billions. Now you see the pattern between the major milestones: 2 centuries difference, 1 century to the next major, now 1/2 century, and you can generate a logarithmic plot, and you can easily fit a straight line. No, it's going to converge, obviously, because the next thing is going to happen not 1/2 century, but 1/4 of a century in 2015, where many people claim that computers will be as fast as human brains for the first time. And then we will have an infinitude of additional milestones, and they are going to converge in 2040, which is the omega point, which I like better than the singularity. I like omega much better than singularity, because that's what Teilhard de Chardin called in 1900 when he said humanity will reach its next level. Also, I like it because omega, it sounds so much like, oh my God. There's only one problem with lists like that, which is that actually omega should not have, will not happen in 2040. It should have happened already in 1540. In 1540. I can prove it to you. At the turn of the millennium, Life magazine made a list of the most important inventions, or most important events of the millennium. And their number one was the invention of the printing press, 1444 by Gutenberg. And then the second most important event in the history of the past 1,000 years, according to Time Life magazine, was the discovery of America through Columbus. Of course, many people know that other people before Columbus, like Leif Erikson and probably others, also discovered America, but Columbus did not become famous because he was the first to discover America, but because he was the last to discover America. And now let's look at the next, at number 3 in Time Life list of most important event, and that was the Reformation, according to Time Life magazine, probably because it was the only major religious movement of the past 1,000 years. And you see, there's a pattern, 96 years, and then between these two events there are exactly 48 years, and then half of that, 24 years, you know, it's about to converge in 1540, you know. And so, of course, there never has been a shortage of prophets claiming that the end is near. And maybe all of this is just a byproduct of the way we are allocating internal memory space to events in our past, because look at yourself. Most of your mind is occupied with things that happened recently, yesterday, a week ago, not so much a year ago, not so much 10 or 20 years ago, etc. And the same is also true, of course, for history books of societies. Entire societies write a lot of history books, but most of the history books are about the most recent events. And not so many, still a lot, but not so many are about, say, the Second World War, and 200 years ago, things. And the further you go back in time, the fewer history books you will have. And of course, this is just a natural thing. You allocate less and less storage space to events that are more and more, or deeper and deeper in the past. So, from that point of view, at whichever point in time you live, it may look to you that the most important things are accelerating exponentially, you know. It doesn't really matter when you live. So, yes, I really have to go. Okay. All right. Think about that. Thank you very much for your attention. Are you saying there's no time for questions?
No, you went right.
Oh, but Ray Kurzweil said he is going to compensate by speaking faster. All right. So.